Hi everybody, today I'll show you how to do problem number 43 of chapter 9. So the problem states, Romeo entertains Juliet by playing his guitar from the rear of their boat at rest in still water, 2.7 meters away from Juliet, who is in the front of the boat. After the serenade, Juliet carefully moves to the rear of the boat to plant a kiss on Romeo's cheek. How far does the 80-kilogram boat move toward the shore it is facing? So, for this problem, I've drawn my diagram. Here, I drew a before and after picture. Here's Romeo and Juliet on their boat. And the boat is 2.7 meters long. The front end, which I'm going to say is this end, the side that Juliet's on, is the side closer to the shore. And I'm going to label Romeo as mass 1, Juliet as mass 2, and the boat as mass 3, which I've defined here as 77 kilograms, 55 kilograms, and 80 kilograms respectively. So in this problem, it says Juliet's going to move to the back of the boat and the boat's going to move forward because it's in water. So the theory behind this is right at the beginning when they're on opposite sides of the boat, the center of mass is somewhere near the middle of the boat. And the theory is that after she moves, the center of mass of the boat is going to be in the same position as it was in before. So what's going to happen is she's going to move back here. The center of mass is going to get closer to the back end of the boat because more mass is back here. Except this center of mass, which I'm going to say is the red dot, is going to be in the same exact place as it was before, except it's at a different part of the boat. So that's what's happening, essentially. So what I'm going to say is I'm going to call where the initial position of the back end of the boat as x is equal to 0. And after the boat moves, however much it moves, I'm going to say is delta x. Okay, so the first thing we want to do then is to find what the center of mass is, the position of the center of mass at the beginning. So I'm going to treat this all like a one-dimensional problem, and I'm going to say that the initial x value, the center of mass of the initial x value is equal to 1 over m times the sum of m times mass times x of all the particles, which, yeah. So what that becomes is, oops, that's a 1, not an I, plus all over, or times the 1 over m, which is the total mass. So I'm going to write that out as. And what's going to happen is now we just start plugging in values that we know, where M1 is 77 kilograms. His initial position is, we defined it as 0. Juliet's weight, kilogram, 55 kilograms. Her position is, she's at the other end of the boat, so that means she's 2.7 meters away from 0. So we're going to call that 2.7 meters. Then M3 is 80 kilograms. And if we take both people out and we just look at the boat for a second, and we assume that the boat has constant density throughout, and it's like a symmetrical boat, even though I didn't exactly draw it that way, we would know through intuition that the center of mass must be at the center of the boat. So that means that's going to be at 1.35 meters, which is half of 2.7 meters. Then I'm going to put this all over the total mass, which is 77 plus 55 plus 80 kilograms. We put that all into our calculator, we would get 1.210 meters. And that's going to be where the center of mass is, if we think about this as like a number line. Next, we want to find where the x, or we want to find the change of x. And so what we're going to do is we're going to set up another statement. So the x final, the center of meter, so what am I saying? The center of mass afterwards is going to be this found using the same formula. Okay, Romeo's position is his initial position, which is x0 plus delta x, because that's how far that way he moved. Alright. And this right here is x1, so Romeo's position initial. Now we're going to add that to Juliet's position. She is also now with Romeo, so that means they're going to have the same x coordinate, which is going to be x1i, Romeo's initial coordinate, plus delta x, the change in the boat's position. Now the boat is going to move. Now the position of the boat is going to be 1.35 meters plus delta x, since it moved that much forward. So we're going to call that, right now I'm going to write 1.35 meters as the length divided by 2. So the midpoint of the boat plus delta x. Do the same thing. Put this all over the total mass. This is all in variables right now. This is big M for total mass. I'll just write a T there. Now I'm going to start plugging in numbers. Since we said that the final center of mass and this initial center of mass is going to be at the same place, we can say this is at 1.210 meters, since that's where we got up here. Start plugging in numbers for the right side, and we get 77 kilograms for mass 1. Initial position 0, 0 plus delta x is going to be delta x. Mass 2 is 55 kilograms. Initial position, same as, since they're at the same place now, it's going to be at the same position, delta x for Juliet. And for the boat, which is 80 kilograms, that position is going to be at L over 2, which is 1.35 meters, the midpoint of the boat, plus the change in the position. And we put all of that out of the total mass, and now I'm going to write out these numbers, kilograms. Okay, I'm going to simplify the numerator first, just to make it a little bit more clean. All over 212. Okay. So what I'm going to do here is I'm going to multiply 212 to the left hand side and then subtract 108 meters from that. So that would get us 148.5 meters. And that leaves us with only the delta x terms on the right side, which is 77 delta x, 55 delta x, and 80 delta x, which adds up to 212 delta x. Therefore, delta x is equal to 0.700 meters. And that is your final answer.